Hello, and welcome to episode 6 in my how-to series. So, you've been after a model for years, but just can't find a kit the right scale for the right price that's accurate enough. And you're thinking, what about designing and 3D printing my own model? I'll just design it on the computer and 3D print it myself. People are doing it all the time. How hard can it be? Well, I'm sorry to tell you, but hard is an understatement. It's not as simple as just scanning in some plans, pressing a button and waiting for your printer to spit out the parts. Until that glorious day arrives, we'll just have to design the parts ourselves. Of course, there are some great sites out there where you can buy and download 3D models and print them out yourself, but this video isn't about that. In this episode, we're going to take a look at a beginner's guide to 3D software for the model maker. There are a lot of brands of software out there, and we'll be taking a look at 3 in particular, but more on those later. First of all, I must warn you that unless you just want to make models of very basic random shapes, you're in for a very steep learning curve. I'm not going to lie to you, this software is complicated and takes a long time to master, but if you stick with it, you won't regret it. Being able to create your own parts or models is incredibly liberating and very rewarding, knowing that the model you have in your hands you designed yourself. Okay, if you're still watching and I haven't frightened you off, let's get started. First of all, let's look at what you're going to need. Obviously a computer, but what sort of specification? Well, most software will tell you what the minimum requirement needed is, but basically you're after one with a gaming specification. If you're on a budget, go for a machine that you can progressively upgrade, as your experience in creating more complex models improves. Start with a computer with a good processor speed and as much RAM as you can afford. RAM can be increased and upgraded later. These days hard disks are easily big enough, so that's something you don't need to worry about. However, you will need a graphics card, one that isn't built into your motherboard, but can be upgraded as your skills develop. You can spend crazy amounts of money on graphics cards, but my advice is to start with what you can afford, and then upgrade later. Often the requirement is dictated by the software's image rendering needs. Rendering is the process where a 3D model is textured and lit in an environment to create a realistic image. This process takes a lot of processing power and can mean a rendered image can take 1 minute for a high-spec machine to 10 minutes or more for a basic computer. This is where the graphics card makes the biggest difference. Something that will make your life a lot easier is investing in a 28-inch 4K monitor. The workspace you need on your screen for 3D modelling is significant, as there are so many windows and controls active at any one time. It'll also allow you to see far more clearly the model that you're working on. You don't need a big monitor, but it will make your learning process less stressful. Many 3D artists use a pen and tablet to create their 3D models. A graphics tablet is a great tool, best suited to sculpting figures and creatures. For now, we just need a basic mouse and keyboard. Now, let's look at some software. There are lots of brands to choose from, and these fall into 2 main groups, free and not free. You used to be able to just buy the software outright, but with piracy, software companies now only make their products available free or by subscription. The subscription software is excellent and used by many effects studios. The free software is often limited in its capabilities and difficult to use. We need software that's capable of outputting either an STL or OBJ file. This is the format a 3D printer will need to bring our model to life. There are a couple of programs out there that are not only free, but incredibly powerful, and we'll take a look at those later. I use Cinema 4D. It isn't free, but I've been using it for years, and it's good software to show you the basic techniques which you'll need. In fact, I use Cinema 4D for the animated intros to my videos, so you can see how powerful the 3D software can be. Whatever software you choose, ultimately they all deal with the model that you're creating in basically the same way. First of all, let's look at some fundamentals of design in 3D modelling software. Any decent software will be able to carry out the following techniques, but how will vary. When you open up your software, you'll often start with the default cube. This is one of many primitive, ready-made objects that you can use as a base to build from. You'll be able to view and work on your model not only from the front, side and top, but also in perspective. Objects are defined in 3D space using X, Y and Z coordinates. Their size is also defined using X, Y and Z. You can regard this as length, width and height, so you can judge the size of your objects. The default cube is just one of several primitives that you can start with to design your 3D model. Some are more useful than others. Designing and modelling an object is more an exercise in problem solving, and it begins by choosing the closest primitive to the object you wish to model. Every object you create can be defined and edited in three main ways. We're going to start with the default cube and divide its sides up into segments we can edit individually. You can choose to edit the points, edges or faces. These can either be moved, rotated or scaled. Simple objects with few faces or points are quick to render, but this resolution means that they're not so good for curved surfaces and creating smooth 3D prints. More points means more complex, which means bigger files, longer render times, so try and keep the point count down where you can. The faces are often referred to as polygons, so the more polygons you have, the more detail your model will have. Low polygon or low poly models are often used for computer games, as they present less information for the computer to process, but they're not what we need for a detailed 3D print. There are often several different ways of creating the same object, and I'll show you a few here. Some are easier than others, some take less time to render, but there's no wrong way. Often creating an object is more of a puzzle, deciding which method to use to recreate what you want. Some methods are easier than others, only with practice will you learn what to use and when. So, we have our cube, but we want to divide it up further. We can do this with loop cuts. These are slices through the cube which create additional faces. We can do this on any axis, and in some software with additional options. Sometimes we need to round off or bevel an edge. The bevel tool is common on most software and allows us to bevel selected edges as much as we like. We can also adjust the number of steps, which determines how rounded the bevel is. But don't get carried away with this tool, as more steps means more polygons, which slows your computer down. Just be selective. If you have a large part, use more steps than you would on a small part that doesn't need the extra detail. One of the most used tools is the extrude function. Just select a face, then click and drag. Every time you click and drag, you'll get another step to your extrusion. You can also use this to extrude back into your part, creating a cavity. So far we've been using a technique called polygonal modelling, where we've taken a primitive object and reworked the polygons to produce a model. This common technique creates the most reliable models for 3D printing and is something well worth practicing. The reason it's so preferred is to do with normals. But what are normals? It's so hard to tell these days. Well, every polygon of every model has a front and a back, or an inside and an outside. A normal is the indicator that shows you that the polygon is facing the right direction. Here, the white lines on the yellow polygons show that the normals are all correctly facing out. Polygonal modelling helps keep the normals facing the right way round. But what if we're modelling something more complicated, like a cube with a chunk cut out of it? Well, there is a way. We need to use the Boolean tool. This literally subtracts one object from another where they intersect. This could be achieved with polygonal modelling, but with difficulty. Boolean tools are often frowned on, as they can in some cases create problems with normals. Our original cube is fine, but the cube we used to make the cut with has created new faces, and what we're actually seeing is the back of these faces. The normals are facing the wrong way. This can cause a big problem when it comes to 3D printing, as the slicer software will interpret the part incorrectly and the print will fail. Fortunately, we can select these faces and reverse or flip the normals to face the right way. Normals are just something you have to be aware of if you want to 3D print your own models. It's not hard, it's just knowledge you'll need to know when you debug your model for printing. Another form of modelling is spline modelling. A A spline is just an outline shape made from connected points. Some of these points can make hard corners, others create curves. Once we have our spline, we can do a lot with it. We can rotate it around an axis to create an object. Again, the more steps, the smoother the object, but the more memory it takes. If we take the steps right down, we can create other useful objects. Instead of rotating the spline, we can also extrude it to create a solid object. This could also be created from a primitive cube using the tools we mentioned earlier. Finally, we're going to use the loft tool. This takes several copies of the spline and joins them together to create a smooth, fluid object. Again, this would be difficult any other way. A good example of the loft tool in use is creating a fuselage for an aircraft. From scanned drawings, splines have been created from the aircraft sections. These are then aligned and progressively added to the loft tool, creating one half of the fuselage. The loft is then mirrored to create a solid object and smoothed out by creating further subdivisions to the surface. This is a track link from a Churchill tank. See if you can work out what techniques I used for each individual part. Right, let's start designing something a bit more organic, like a car. We're going to go for the Mercedes-Benz T80, which I've already designed, 3D printed and finished. You can see more on this build if you check out my Project T80 playlist. So that we have something to refer to and build from, 3D programs allow you to import plans as background images. This is our crucial starting point. You need to begin by scanning the images into your computer or downloading them from online. You'll then need to find out exactly how big your model needs to be. You can do this by dividing the overall dimensions by the scale you're working to. Your 3D software will have at least 4 main views: side, front, top, and perspective. Import the correct image into each viewport and then create a basic cube, which is the exact dimensions of your chosen model. You then need to scale and align each of the background images to the cube. Once the background images are the right size, you can delete the cube. Now we can start making the car body. This is the most common technique to model an organic mechanical form and is available in most software. We start with a plane, just a small, flat square. Aligning one side of this plane with the centre line, we begin extruding it in stages to trace the profile of the car. As we go, we can adjust edges and points to try and recreate the gentle curves of the T80. We don't have to use the small squares all the time, but it can make it a lot easier to deal with the more extreme curves as the process goes on. By extruding and filling the gaps, we eventually form a mesh, which is a relatively low polygon model. If we were to print the car body like this, it would be heavily faceted. Once you get into this form of modelling, it's actually strangely very relaxing. Anyway, sometime later, this is what you get: half a car. Wherever possible, the mesh is made from 4-sided polygons, known as quadrangles. We don't want to use triangles if we can help it. Triangles are bad. Don't ask, just trust me on this. We can then mirror the body using a symmetry tool, and then comes the magic. Next we apply a subdivision surface. This divides the surface further and smooths it out for us, giving us our finished car body. The rest of the car is designed using all the previous techniques we looked at. Okay, now that you've seen some of the principles, let's take a look at some software. We're going to look at free software, so you can see how you get on without spending a fortune on something you may regret. I'm not going to show you how to use these programs, as there are plenty of YouTube videos that will do a far better job than me. I'm just here to point you in the right direction. I'm going to recommend 3 programs, the first of which is Tinkercad. It's made by Autodesk and is cloud-based and aimed at children, but that's not the point. If you're a raw beginner, give it a try. It'll give you confidence to use the 3D workspace and practice manipulating objects. It's a very capable piece of software and will make an excellent first step on your 3D journey. The next piece of free software is Fusion 360, also from Autodesk. This is excellent software and will do everything that we've previously looked at. It's primarily aimed at users with an engineering background, in that everything is clearly dimensioned, so it's great for creating mechanical objects. It uses something called procedural modelling, which allows you to go back through the history of your object and make alterations retrospectively. This is great if you're making functional mechanical parts. An excellent example of Fusion 360 can be seen in the design of the Marble Machine X on the Wintergarten YouTube channel. This project is fascinating and has been going quite a while, but is entirely designed in Fusion 360. Martin has been learning on the go, just like us. So, you've mastered modelling hard objects, but you want to create something like this guy. I know, he's pretty cool. It's hard to believe, but you can with my final recommendation, Blender. Blender is free open source software, constantly evolving, and it's amongst the most powerful of any 3D modelling software out there. In fact, it's often used for CGI in movies, it's that good. But surely, I hear you say, there's got to be a catch. Well, put it this way, it's not the easiest to learn. However, if you put the time in, the only limit is your imagination. It's fantastic. Just check out Ian Hubert's YouTube channel and watch his films Hyperbowl and Salad Mug, both of which were created with Blender. He also makes some very entertaining 1-minute lazy tutorials, which are worth checking out, although I think he drinks way too much coffee. My advice for learning Blender is to take baby steps. Don't get overambitious or you will fail. Set yourself simple goals to start. Learn the basics. Blender will do all the modelling we looked at earlier. You don't have to use it to make a movie, but you could. Again, there are plenty of tutorials on YouTube, but to start, subscribe to Andrew Price, the Blender Guru, and follow his How to Design a Chair tutorials. It'll get you started learning the basic interface before you move on to more complex projects like his donut tutorials. Flipped Normals also has some good sculpting videos that are well worth checking out. Blender is far from intuitive, and I would advise keeping clear of materials, textures and lighting to make pretty renders until you're more experienced. One of the great things about Blender is its sculpting interface, which we touched on earlier. If you want to try figure or creature sculpting, this is great software to start with. Okay, now we've designed our parts, we need to divide up our model and prepare it for 3D printing. That's as easy as taking your part and exporting it as an STL. Then it's just a matter of firing up the printer and pressing go, except it's seldom that easy. In the next episode, we'll look at 3D printing parts on an FDM printer. What the important settings are you need to know about, what you can expect, and how to get a good result. I hope you found this episode of my how-to series interesting. If you did, hit the like button, subscribe to my channel and share with your friends, but make sure you click on the bell icon so you get notified when my next video goes live. Don't forget to check out some of the other projects on my channel to discover more model making techniques. If you have any questions about issues raised in this series, just leave them in the comments and I'll get back to you. Thanks for watching.